Hi, I'm following along with Paul McWhorter's uh, Fusion 360 and 3D printing lessons. I've been uh, printing and using Fusion 360 for years, but I'm following his lessons so I can get some teaching tips. He's a great teacher, and I'm looking to pick up some tips from him for when I teach it to the teams at our library. I've been posting a few videos of uh, past and current projects that I've been working with just while he's doing this, just to maybe give another perspective on things you can do with your Fusion 360 and your printers. So others have been following along too, and one of them is Lori with Lori's Robots. And her last video, she had a track robot in her video, and I also like tracks for robots rather than wheels, so brought to mind a project I was doing a while back, and so I thought I'd show you what I want to share today. So my idea with a track is to make a continuous track. Most of the robots that you see out there have segmented tracks that are held together either with PLA filament pieces or screws or something, or long bolts or something. Well, my idea was to make a continuous one. This is actually made out of Semi-Flex PLA, which is not Ninja Flex, which is really flexible, and it's just got, like I say, as the name says, it's semi-flexible, so it moves around, but but you don't have the stretch that you do in the other one. This here, you can stretch it just because of the form that it is, but the material itself doesn't stretch too much. But you can see that's the shape that I chose to do, and it's just repeating all the way around. So if you have an idea how I did this, you can stop the video and maybe leave a comment, and you can compare and see how if the way I did it was similar to what you would do. Got a feeling I threw a wrinkle or two in there. So anyhow, we'll get on with it now. So like you said, this is pretty cool stuff, and I've made some idlers for it, or drive wheels, and you can see that you could make yourself a nice machine that'll do it. The only thing is that I realized after I made it, if you can see that the tops are flat on there. Most of your tracks that you see have some kind of bars going across for traction, and so I thought I'd redesign this with try to make bars along the edges so that it has a little bit more traction, might not slip so much. So there's a couple ways I think that you could do this in Fusion 360. One would be in the previous video on my list, I did a flower pot and did a shell command. I think you could do the shell command. You'd end up with one bottom in it, but you could do a subsequent second operation and remove that, and then you could have something like this. But the reason that I didn't do that is if you've been 3D printing for a while, you probably notice that when you get intricate things like this, that you get a lot of jitter on your printer when it tries to fill in these little intricate things here, and shakes your printer and doing all those small moves and everything. And so I didn't want to go that way. So what I actually do is create this as a round solid and then put the STL over to the slicer, but then use 0 infill and no top layers and no bottom layers. And I use, I think, 3 or 4 perimeters just to do that. So when you're doing perimeters, it works its way around the profile, but it doesn't do any of that jittering. It just does, you know, one loop and then another loop and then another loop, and just continuously does it and builds up layer by layer, and gives you a pretty strong unit here that I think that would work. I haven't actually built the robot to put this in yet. I did it a while back and then lost interest in it or whatever. And so maybe I'll have to make a robot and test out my strategy now. I don't think that you wouldn't want to upgrade this to like a giant thing. I think that eventually your stretch would probably come into play as your robot gets heavier, but I think this would be okay for a limited size robot. So let's go and I can show you how I made it. Maybe let's see, go back, share screen, and we'll go to Fusion 360. So like I said, we're making this a circle, and I'm going to do one, and then we're going to go and use the circular pattern and make it fairly easy on us. So we'll start out with just not sure what happened there. Let's start on a new one. I'm going to go do a new one. I think I had played around with that for a while. So we'll do I'm going to do it on the XY plane. We're going to start off with a line, and we're going to make it a 65 millimeter line. And this actually may be in inches, so I might have to change the signs on this. Okay, so in case you've ever, I'm going to hit cancel. So if you've ever want to go between inches and millimeters, you click on the document settings, and then you click on this little settings thing, and my head's in the way right now, but we can change this to millimeters and then say okay. I usually do work in inches, but today I want to work in millimeters. So all right, so got that done. We're in millimeters now, so I can go back and start. So we want our line, and this is actually going to end up as construction line, but I don't want it construction line yet. So enter. I got my line, and the way I do a construction line is if you right click and then you say normal construction, and you can switch between the two that way. So I generally don't do the normal construction line first. I wait and draw a line, then turn it into construction line. So this is 65 millimeters out. So this is going to be a circle. This is the radius. So we're going to have 130 millimeter radius circle. So to make our little loop for our thing, we're going to put a circle here and make it 5 millimeters. And then we're going to dimension that with a D, and we're going to make that so that it is, I like to move my dimensions out. You can move them out here. So I'm going to make that also 5 millimeters from the end of the thing. So that's done. Escape to get a dimension in. We'll scroll in here. So we need to draw one side of this, and then we're going to mirror it to the other side, and then we'll do a circular pattern of everything. So we'll do a regular line here, and we'll just do it, and we'll finish up. Now we wanted, like Paul says, want to use constraints. So we got the tangent constraint. So we want to make that tangent to this. Wow, that moved up. So we're going to escape out of tangent. We want to move this over so it's close, but we also want to make this horizontal vertical. So we want to, this is a point that is, we've already dimensioned. So there we go. So it's going to, our line's going to be there. But now we need to dimension that. So we want to make from here to here. And we want to make it, oh, just a 0.5 millimeter because we want them almost to touch. All right. Escape out of that. Now, on that flat one I did, what I basically did was just drew another line all the way down here. And then that made it flat on top. But this time I don't want it to be flat on top. So I'm thinking that maybe if we do a 2 millimeter line here, and then we do another line in, maybe 1.5 millimeters. And then we come down, and that'll give us a little bar across our thing that we did. So we'll do another line. And we'll bring this one down, maybe what, I don't know, 3 millimeters. All right. So I already noticed something that I don't like is that you got this, like, because we're doing perimeters and eventually this is not going to work out with our perimeters. So let's take away our constraint here. It keeps it perpendicular. So you right click on it and delete that one. So now we can go and we can use our parallel constraint. So we want to say that we want this parallel to this. All right. Turn this around. I don't know whether that's going to matter so much or not. Let's just try it that way and see what happens. So we could get rid of this constraint. Let's just leave it the way it is, I think. So let's just leave it like that. All right. So we want to mirror this. So let's go to create and a mirror. And what do we want to mirror? We want to mirror this one, this one, this one, and this one. Okay, and then we want to select the line to mirror it over. So we're going to select the mirror line. So we're going to use our construction line. Okay. Hit OK. And now we got that. We might have to go in and change this. I actually didn't do this ahead of time. So we'll see how it works. Slide it over. I do know that I want about 42 of these objects around there. So let's just see what happens if I do that. So we want to create, and we want to create a circular pattern. All right, so we want to select the objects. We actually want to select all these objects. So let's select them all. And then we want to select the center point, which is this. And we want a full circle. I think 42. I think that's what I did on the flat one. Let's see. Okay, so this actually isn't so good here. It gave us a extra ridge that I didn't really want. So what do we have to do to change that? So let's cancel our 42. We'll go back to our just our one. So we'll get rid of this constraint, this. All right, so that constraint. So now we can actually do another parallel. We can say we want this parallel with this. Well, we can see how that works. So let's go back to our circular pattern. And we want to select them all. And we want to select the center point. And we want to make it 42 of them. Have to do a lot of scrolling in and out when you do this. Now we're going to scroll in and see what it looks like. Oh, that looks better. See, these lines actually cross each other. And when we extrude it, we don't worry about those lines I don't worry about those lines. Paul probably would worry about those lines, but I'm not going to worry about them. But it kind of just gives a little arch there or a little tapered thing. But I like the fact that this is now, you know, even across here. That way, when you do your perimeters, it's going to make how many of our perimeters to fill that in. So that looks good. I like that. So anyhow, we got that. I think we're ready to finish our sketch. Well, we have to hit OK on that. And now we can finish our sketch. And now, like I said, it's just a matter of extruding it. And if you see, let's come in a little bit. So you can see what you've actually, or the blue part is what you're extruding. So, you know, those dots that are outside aren't playing any problem at all. So that's good. All right. And so we want to extrude it maybe 30 millimeters. And hit OK. And that's what we end up with. So that's kind of cool. Doesn't look much like a track at this point, does it? And but that's all we're actually going to do on this. So we're going to go up here and go File. And I don't know whether Paul come across this or not yet, but there's the newer versions have 3D print built in their drop down box. So you don't even have to worry about saving or anything like that. So we just 3D print, comes over here. If you were using Cure or something, or you wanted to automatically go to Cure, you could check this box and go to it. But I don't use Cura, so I don't go to a box. I don't use that box. I just create the STL file and then open it up in that. So it's saying to select, we just want to select the one body, and we want to say OK. And we're going to save this as maybe track. I think I've been doing some, so I'm going to say track 4. Okay, we're going to save it. All right, so we're pretty much done with that. Like I said, everything I'm doing in this Prusa slicer can be done in Cura as well, but with a Prusa printer, all the settings are already there for that. So that we're going to open up an STL, and it's going to say there's our track 4. So we're good, and we're going to open it. All right, so that's what it looks like now. And then if we go to print settings, I think they're probably going to stay the same way because I haven't changed it. So our layers and perimeters, I'm going to just do 3 perimeters. I think if I printed it and it seemed like it was a little too thin, I could jump that up to 4. But we're going to have 0 solid layers, 0 top layers and bottom layers. And I don't know where they are in Cura, but they have the same settings. I've actually done this in Cura with my old printer to make these. When I made the original tracks, I was using a different printer. And then infill, you want to change that to be 0%. So now if we go back to our platter and we say we want to slice this, and it's all sliced, and then we look at our preview of our slicing, and that's what we ended up with, and that's what we're going to actually be printing. So we can zoom in here and we can see what we're going to get. So you're going to get a nice, ribbed track here when you're done. And like you say, you got the you got 4 perimeters for the track area, which makes it a little stronger, and everything else has 3 perimeters. So that's kind of cool. If you do it, well, anything, even if you were printing this as a solid, all these moves are going to take a while to generate in G code. So a little thing about G code, if you haven't been around 3D printing for a while, a G code is a line of code. And if you were drawing a straight line all the way across, doing the bottom layer, making this solid, you could do it with one line of G code. It would tell you a direction and a length and a slope and a length, and it would just draw it X, Y, and Z. And that would be one line of code. Circles sometimes can have, there's G codes for circles, but I don't know whether, I think that these slicers break it up into lots of small segments that you don't even see. I don't know whether they do it, and I haven't looked at the G code on this, but I know from metal working machines that you can do curvature G codes. But either way, all these little short ones here are all going to have their own line of G code. So when you do this, there's going to be a zillion lines of G code, and I'm not going to slice it right now because export the G code, create the G code right now, because it'd probably take 5 minutes to do it. So, but it's fine. It just takes a while to get them all. It'd be nice because all these layers are going to be exactly the same, but the slicer doesn't know that, so it creates G codes for each line. And even though all you're doing is incrementing the Z a little bit each time, it has to regenerate all those. So anyhow, that's how we ended up with this. Like I said, it's going to print in a circle, and then if you, like I said, we're using the Semi-Flex, and you can make it do what you want. Yeah, thing. So that's just a little different thing that you can do on your 3D printer. You never knew you never know what you can do until you see somebody else do it. This isn't an original idea with me. For tank tracks, this is the first time I haven't really seen anybody else using it for tank tracks necessarily. Like I said, I think I saw it making Ninja Flex bracelets with a similar process. And like I say, that's really a soft material, so it would stretch over your hand and maybe tighten up on your wrist or whatever. So anyhow, just wanted to share that today. So hope some people get something out of it. And I keep enjoying Paul's lessons. Thanks for watching.